Hello, my viewers. Welcome once again to a new episode. Today, I'm going to discuss about field capacity and its relevance in irrigation system design. So, field capacity is a very important aspect in designing irrigation system because it is what is going to help you to determine how to schedule your irrigation system so that your crops get enough water at all the times. So stay tuned till the end because today we are going to learn something very important towards designing an effective irrigation system. So if I start with what is field capacity? So field capacity is basically the moisture content that remains after gravitational water has drained off. So when it rains, a lot of water gets into the soil. So this water fills all the pores of the soil. And when all the pores are filled, we say the soil is saturated. So that is what we call the soil saturation level. So once all the pores are filled, you will notice that water starts overflowing on the surface of the soil, or what we call runoff. So when the rain stops, water starts draining. So this will happen for a period of between 24 to 48 hours, depending on soil and also the amount of water that has been applied by rain or by artificial means. So draining will happen, it will continue until such a point that there's no any more amount of water that is draining. So the amount of water that remains, or the moisture content of the soil after all the draining has happened, is what we call the field capacity. So there's also another important level, that is the permanent wilting point. Permanent wilting point is a point at which the moisture content of the soil is not able to meet the transpiration demand of crops. So if you remember from the previous video, we talked about evapotranspiration rate, which is a factor of evaporation from the soil as well as transpiration rate. So if the moisture content of the soil is not able to meet the transpiration rate of your crops, then what happens? Your crops starts wilting. So this will continue until your crops wilt permanently. They will not be able to be restored back. So that is why it is called a permanent wilting point. So the difference between the field capacity and the permanent wilting point is what we call total available water. So that is the water that's available to your crops. So determining this water is very important because it is what you need to maintain at a safe level to ensure that it is available for your crops at all the times, so that when that level is depleted or when that level goes down, now you need to do irrigation. So I'm going to show you how to determine the total available water, what you are going to now to use to schedule your irrigation system so that you are able to meet the crop water demand at all the times. So how do you determine available water? Number one, you will need to first of all determine the effective root depth of the crops, because you understand crops comes with different root zone depth. Some crops have got deeper roots, some crops have got shallow roots. So you will need first of all to determine the effective root zone depth of your crop. Once that is determined, then you identify the depth of different soil layers within the effective root zone depth. Because soil comes in different layers, sometimes you understand you will have within the effective root zone depth, say if it is 1 meter, within that 1 meter, you will have different soil layers. You could have fine tilth, you could have loam, you could have sand, you could have different soil layers. So you'll need to determine the depth of different soil layers within that effective root zone depth. Then once you do that, you determine the soil texture and percentage of stone or gravel of each layer. So you will understand later why we do that. So the percentage stone, if for example you can see from the effective, okay, like if you taken a soil sample and you've seen within those different soil layers, if for example a layer of 30 centimeter or 20 centimeter is say sandy or it is loam, then you'll determine within that loam what is the percentage of gravel or stone that is available. So once that is determined, then you will use, you can see from the table that I've provided, as you can see from the table, there's different grouping of water tension, like there's 0 kPa at saturation point, then 0 to 20 kPa, then up to 100 kPa. So water tension group is just how tightly water is held in the soil and how that water is available to plants based on soil water tension. So normally it's measured using a tensiometer. So from the table you can also see soil textures, like we have sand, loamy sand like that. So if for example you are dealing with a water sensitive crop like vegetable, and you've identified that your soil is sand, and using a tensiometer you've measured that the soil tension is 20 kPa. So you'll come to this table, then you identify that the readily available water in terms of millimeters per meter is 30. So if the soil is loam, for example, and you are dealing with most crops, such as most fruits crops, then you'll identify if your water tension is 40 kPa, then you will determine that the readily available water is 70 millimeters per meter. So that is how you will use that table. So once you do that, and you have identified the raw value for each soil texture in terms of millimeters per meter, then now you will reduce the raw figures by the percentage stone and gravel in the soil. Like I said, first of all, before you select the crop water tension group, you determine the soil texture and the percentage stone and gravel for each layer. So then once now you do that, so when you've identified the tension group, or you have identified the raw value for each soil texture, or for the soil texture that you identified, if you say you identified it as 70 or 30 millimeters per meter, then now you will reduce those figures by the percentage stone and gravel in the soil. So once that is done, then you will multiply the thickness of each soil layer by its adjusted raw value. So if, for example, you identified that as 30, based on the example that I was giving from the table, you identified that your soil texture is sand, and you are dealing with a water-sensitive crop like vegetable. Then using a tensiometer, you identify that the soil water tension is 20 kPa, and you've determined that the readily available water is now 30 from this table. So if you've reduced it, for example, the percentage gravel in your soil is 20%, so you reduce that by 20%. So that means that your readily available water will be 80% of 30. So based on that value, now you multiply the thickness of the soil by its adjusted raw value. So if it was 30 and you reduce it by 80%, by 20%, so that means that now the readily available water that you are dealing with is 24 millimeters. So that is what now you will multiply by the thickness. So if the soil thickness, for example, was for the soil was sand, or the layer was sand, and that sand you've seen, its level is say 100 millimeters. So you will multiply that thickness by the value you've got, which is 24. So it is 24 times 0.1, because 100 millimeters is the equivalent to 0.1 meters. So you multiply 24 by 0.1. So that is now the value that we will call the adjusted raw value. So finally, you will add the raw the row for each soil layer to obtain the total root zone depth. So for different soil layers, you'll do that. You'll continue doing that for different soil layers. So once you determine that, now you sum them up all together. So that is what will give you the raw or the readily available water of the soil. So once you've determined the readily available water in terms of millimeters, say you determined it as 24 millimeters, then you use the value for ETC from the previous video. You remember we discussed about ETC, which is crop water requirement. So if your crop water requirement, you determined it as, say, 8 millimeters, and from the field capacity or from the readily available water, you've determined that the readily available water is 24 millimeters. So you'll divide the readily available water by the crop water requirement, which is 8 millimeters. So it will be 24 divided by 8, which is 3. So that means that your irrigation schedule should always be after 3 days. So after every 3 days, you need to irrigate so that your crops does not miss the moisture content or does not miss the water that is sufficient to meet its transpiration rate. Because if it does that, then your crops will wilt. So that is it. That is how important the issues of field capacity is, the readily available water, the permanent wilting point. So all those aspects are very important in determining how you schedule your irrigation system. So that is how you determine or how you calculate that. So thank you very much for being with us till the end. I invite you to like and subscribe these videos, because the next video we're going to discuss about site survey. So I'm going to show you how to conduct a proper field survey for an irrigation system. So this is now where we are starting to get deeper into how to design an effective irrigation system. So all this information that I was telling you was building it up to this level. So now we are going to start how now to do a proper survey. Then we'll now come how to, once you determine those field parameters, now how to put it all together to develop a proper and effective irrigation system. So if you need any consultancy, if you need any help or consultancy in irrigation system design, installation and maintenance, do not hesitate to contact us on the number on your screen. So thank you, and see you in the next one.